In this video, I'm going to solve a couple of examples based on three-phase load. Both of them are star-connected loads. So here is the first question. Find the each phase voltage and line voltage of the following circuit when VAN equal to 120. So whenever you see VAN without any phase angle, oops, where are we? Okay, right here. So whenever you see VAN without any phase angle, you can say, you can take that phase angle as 0. So I have VAN equal to 120 at an angle of 0. One important thing, whenever you see a star connected source or load, all we know VAB, which is a line voltage, equal to square root 3 times phase voltage, which is square root 3 times VAN. Okay. Another important point is V line leads V phase by 30 degrees. Okay, so whenever you draw vector diagram, so here is VAN, VBN, VCN, each of them are 120 degrees apart, same magnitude. Now VAB is nothing but VAN minus VBN, right? So here is my negative VBN, this must be 60 degrees, and here is our VAB, sum of those two, this must be 30 degrees. So VAB, which is line voltage, leads phase voltage by 30 degrees. Okay, so the question he's asking about, he gave us VAN, which is 120 at an angle of 0. From there, he's asking about each phase and line voltage. So if you know VAN equal to 120 at an angle of 0, what is VBN? It must be the same magnitude at negative 120 degrees. VCN, same magnitude at negative 240 degrees. This negative 240, so basically this is negative 240. Okay, you can indicate that as a plus 122. So you can indicate this as plus 120, but we'll follow a sequence. So we'll follow 0, minus 120, minus 240. Okay, now that's VAN, VBN, VCN. Now what is VAB, VBC, VCA? So if we look at VAB, VAB must be square root 3 times VAN, which is 120 at an angle of 0, plus 30 degrees, because VAB leads VAN by 30 degrees. So VAB equal to square root 3 times 120, it's a 208 at an angle of 30. That's VAB. Once we know VAB, what is VBC? Again, it's 120 degrees apart. So 30 minus 120, so which is minus 90. VCA 208 at an angle of 30 minus 240, which is 208 at an angle of minus 210 degrees. Okay, that's how we'll find phase values and line values if you know one of the voltage. Okay, now here is the next example. Three similar impedances. So the three similar impedances is nothing but it's a balanced load basically. Okay, it's a balanced load or connected in star across a 400 volt supply. One important thing in three-phase system, the given value always line value. Okay, unless we specify, we always take that as a line value. The line current is 10 amperes, so it is taking, I think I indicated the arrow going out, but in reality it is taking 10 amperes of current. Power factor is 0.8 lagging, so power factor of the each phase is given. Find the impedance per phase and real power, reactive power conjugated by the load. Also draw the vector diagram of the circuit. So from the power factor, we know cos theta equal to R over Z or P over S. With this value is 0.8. Okay. Now we don't know R value, we don't know Z value, but I can find the impedance per phase equal to, always use the phase values, VPH over IPH. Okay, over IPH. You do not have this formula, Z line equal to V line over I line. I saw many students writing this, but we do not have such thing. To find phase impedance, it's always VPH over IPH. Line impedance, this is not the way you find the line impedance. Okay, now the phase, I know phase value, which is 400 over square root 3 divided by IPH is 10 ampere. Okay, so 400 divided by square root 3, which is 230.94, it's right here. So 230.94 divided by 10, ZPH equal to 23.094 ohm. So once I have ZPH, I can find R value. So R must be cos theta times ZPH, which is 0.8 times 23.094. That value is right here, 18.47 ohm. Okay, that's the resistance value. Now the reactance, since it's a lagging power factor, lagging means it has resistance, inductive reactance, okay, R plus JXL. If it has leading power factor, then it is resistor and capacitive reactance. So once I know R and Z, I can find XL. What I did here, I found this angle minus 36.86, which is cos theta. Cos theta equal to 0.8. So theta is cos inverse of 0.8, which is 36.86. My apology, this must be plus angle though. Okay, so Z value is 23.09 at an angle of 36.86. If you convert this polar format into rectangular format, you will find R value or Z value. R value and XL value. That's one way. Here I already found R value by using cos theta, ZPH, and I can find XL value, Z square equal to R square plus XL square. Based on this, I can find the XL value. So if you find XL equal to 13.85 ohms. Once we have R and XL, he's asking about P and Q. Okay, we know that P equal to 3 times VPH IPH cos theta. Okay, we know VPH, which is 230.94. In star, we know that IL equal to IPH. Okay, that's another important point you need to remember. So which is 10 and cos theta is 0.8. So if we solve this, we should end up with the same number, which is 5542.56 watt. That's P. And you can find Q equal to 3 times VPH IPH sin theta. Okay, so theta we just found 36.86. If you substitute 36.86, you will end up with 3 times 230.94 times 10 times 0.6. Sin theta is 0.6 in this case. So you will end up with 4156.92 volt ampere reactive. That's the Q value. So this is how you will find P and Q. You can use another formula for P and Q, which is square root of 3 VL IL cos theta. Okay, or you can use 3 times IPH square times R load. Okay, to find P value, you can use any one of these 3 formulas. Here I use different methodology. So I found S value. S is nothing but 3 times VI conjugate. So once you have that value, this is the S. This is called complex power. Okay, complex power is nothing but S equal to P plus or minus JQ. If it is lagging power factor, it is plus JQ, leading power factor minus JQ. So that's how we'll find PQ. And S is nothing but another way. This is called apparent power. In volt ampere or kilovolt ampere. Complex power is nothing but, you will see P plus JQ. Apparent power is, you will see the whole number, which is square root of P square plus Q square. Based on that, I found the apparent power. Okay, I'll stop this video here. I'll continue with more examples in the next videos. Thank you.